Hello, welcome back to another episode of Nemo Academy. Sorry, it's been a while, life has been busy, but I fixed the audio quality. This video should be much better. Today, we are going to design another sheet metal component. Here it is. So, it's just a simple component. We have a sheet metal part with a few flanges, and those flanges have some holes in them. And there is a slot that is cut into the sheet metal part that happens to go through a bend. Now, if you remember from our last episode on sheet metal, you know that the defining quality of a sheet metal component is that you can flat pattern it. That is to say, you can unfold it, and then you can have a 2D representation of it, which you can cut out with a laser, and then you can fold it up using folding machines, and you end up with your properly folded sheet metal model. In this episode, we're also going to have a look at how to make a drawing from the sheet metal component. So here we've got the folded model of it, and here we've got the second sheet, which will have a drawing of the flat pattern showing where you need to fold. So let's get to it. We'll go ahead as always, and we'll start off by creating a new file. We'll come to File, New, and then we'll click Metric Sheet Metal Millimeter.ipt and click Create. Wonderful. Okay, so we're going to get started by drawing the first part of it, which is this flat back portion. So in our part, we'll come to 2D Sketch, and we're going to draw on the XY plane. Next, we're going to do a center point rectangle. So we'll come under Rectangle at the top left here, and pick 2-point center rectangle. Next, we'll click the origin. And now we're going to type in the 2 dimensions that will make up the back of the sheet metal part. So we'll say that it's 84 wide, and hit the tab button to flick between the 2 dimensions. And we'll say it's 58 tall. Great. So we've got 84 and 58. Great. Next, we'll click Finish Sketch. We'll rotate our view. And next, what we're going to do is click on the Face command to create a face from this profile. We'll click Face. And because we've only got one closed profile, it's already picked up on it. Now, we'll go ahead and create our face and quickly talk about the sheet metal thickness. So by default, it's 0.5 millimeters, but we want to make this a chunky boy. We want to make it 3 millimeters thick. So we're going to come up to Sheet Metal Defaults. We'll click the button. And here, I'm going to untick Use Thickness from Rule. And we'll change the thickness from 0.5 millimeters to 3 millimeters. Next, we'll change the material from generic to aluminium 6061. Now, strictly speaking, this isn't the proper way of doing it. You should be creating a sheet metal rule, but that's another video for another time. We'll go ahead and click OK. And now we'll see that our face has gotten thicker. If we use the measure command using the hotkey M, we can measure the distance from the front to the back, and we can see that it's 3 millimeters. Fantastic. Okay, next what we're going to do is we are going to create a few flanges. So this is going to be one flange, and that is going to be another flange. So to do this, we'll go to the Create Flange button. And now we'll click this edge here and this edge here. Here we have the flange creation dialog. We can do things such as changing the direction of the flange, or changing the position where the bend takes place. But in this, we are just going to change the distance from 25 millimeters to 64 millimeters. And click OK. Using our measuring tool, by hitting M, we can measure the distance from the front here to the back. And we can see that the total distance is the 64 millimeters that we prescribed. Next, what we'll do is we will create the 3 lower flanges. 1 will come from the rear face, and 2 will come from the side faces. We'll create the rear face first. Let's start by creating, we'll come to, oops, here we go. We'll go ahead and we'll create the lower flange first. So we'll click Create Flange, and then click this lower edge here. And we will reduce the distance from 64 millimeters to 24 millimeters. We can see that it is cutting into the material. What we want to do is we want to create this flange below the existing material. To do this, we're going to change where the bend position is. We can change it using the dialog button here. If you play around with these different icons, you can see how the bend position gets changed. We will click Bend from Adjacent Face. And now we can see that an additional material has been thrown at the bottom. Next, what we want to do is create the 2 front flanges. So we know that by using our measuring tool, we can see that these flanges are 26 millimeters wide, and they happen to be 38 millimeters from the back. We'll go ahead and we will create a flange, and this time we're going to pick this edge here. Now, the flange that we're creating, we don't want it to go the entire length of the flange. So what we'll do is we will limit it with an extent. Here we can expand out the flange creation dialog, and we can change the width extents from edge to offset. Here we can change offsets from both sides. I'm just going to change one to 10 millimeters so you can see. And here we can see that that edge is 10 millimeters displaced. We're going to change that to 32 millimeters. And the other offset, which is to this edge here, to 0. We'll make sure that it's 24 millimeters in distance, and then we'll click Apply. We can see that a bend relief has been included here according to the sheet metal rules. Next, we'll go ahead and we'll do the same on the other edge. And it's already inherited the width extents that we prescribed earlier, which is 32 millimeters from the back and 0 from the front. We'll go ahead and click OK. Great, looking good so far. What we're going to do is we are going to add in these chamfers from the other model. So that's very straightforward. We'll come along here and we'll click Corner Chamfer. This is no different from the regular chamfer tool, except it's smart in that it just picks the edges that will be chamfered on a sheet metal part. So we'll go ahead, we'll pick these edges, 1, 2, 3, 4, 5, 6, and we might just reduce the distance to 4 millimeters and click OK. And there we have 45 degree chamfers on each of those corners. Next, what we'll do is we will go ahead and create these holes. 1, 2, 3, 4, 5, 6. So this works just in exactly the same way as you would with a regular 3D model. We'll go ahead and we'll create a 2D sketch on this surface here. And on this sketch, we're going to draw 4 points. So I'm just going to place them arbitrarily, 1, 2, 3, 4. And then we'll use some constraints to fix them into place. So we want this hole to be in the middle of this flange here. So there's a few ways of doing this, but the way that I like to do it is to throw in a horizontal constraint between the point and the midpoint of this flange here. I'm going to do the same for the opposing end. Next, what we want to do is make sure that this point here is vertically aligned with this point here. So we'll create a vertical constraint between this point here and this point here. We'll do the same on the left. Vertical constraint between the lower point and the upper point. And then we'll hit Escape. Next, you'll see that if we were to move around the points, they stay aligned with one another, which is good. We need to make sure that these upper points are horizontally aligned with one another. So we'll create a horizontal constraint between this point here and this point here. Great. Okay, next we need to fix their positions in space with some dimensions. So we'll go ahead and we'll add in a dimension between this point here and this edge. And we'll say that that is 8 millimeters. We'll do the same on the right, 8 millimeters. And we will also say that these points are 8 millimeters from that front edge. Looking good, looking good. Okay, next we'll click Finish Sketch. And we'll rotate our view. And we'll come along and click Hole. So we're going to create some holes. These are going to be very straightforward 6 millimeter holes. So we'll make sure that we're creating a simple hole with no seat. The termination goes all the way through with a diameter of 6 millimeters. And we'll click OK. Wonderful. Next, we want to create these holes on the back. There are also 6 millimeter holes, they're just on another plane, so we have to create another sketch. We'll go ahead and say start a 2D sketch and click that surface. And as before, we'll go ahead and draw 2 points arbitrarily. And now we'll use some dimensions and constraints to fix them into place. So firstly, we'll say that they're horizontally aligned with one another. So we'll click a horizontal constraint. Click this point here and this point here. And we'll go ahead and we'll add in a dimension that will position these holes 18 millimeters from the top there. Lastly, we'll go ahead and we'll position them relative to the origin. So we will say, we'll add in a dimension between the origin point and this point here. And we'll say that that's 22 millimeters. And same on the right, 22 millimeters. Looking good, looking good. We'll say Finish Sketch. And again, we'll create a hole using the hole command. And because these are the only 2 points that we've drawn, it will pick up on them automatically. And we can click OK. Excellent. Okay, home stretch. We've got 2 more things to draw. The first one is we have to cut out these triangular sections so that the flange is a bit more streamlined. So this works exactly like 3D modeling. We'll come along to the side here, and we're going to create a 2D sketch. And we'll draw the sketch on the side. Great. And we're going to draw a straight line that will come from this top point here and approximately down to there. And we'll click on the edges. All right, so we'll use dimensions to get the size approximately correct. We'll say dimension between that point there and this point here. And we'll say that that is 10 millimeters. And then we'll do the same from the bottom. We'll say that point there and this point here. And we'll say that that's 24 millimeters. Great. And we'll click Finish Sketch. And now we can use the Extrude command from the 3D Modeling tab, or alternatively the Cut command here. The problem is the Cut command will only cut one side of it. It works like the Extrude command, but I find that the Extrude command will work better in this case because we want it to go through both. So we'll say 3D Model, come to Extrude, and now we'll just use our regular extrusion to cut to this side here. And we'll click OK. Lastly, we want to get rid of these sharp edges. So we'll come back to the Sheet Metal tab, and we'll use a corner round. It's exactly like a fillet, except it just makes sure that it's just doing it on the plane of the sheet metal. We'll pick these 4 sharp edges, 1, 2, 3, 4, and click OK. Looking good, looking good. Okay, the last bit is to model this slot here. And the slot's special because it happens to go through one of the corners here. So we can't use a regular extrusion, or if we did, it would be a little bit tricky. So what we're going to do is we are going to unfold the sheet metal. So to do that, we'll come along here and we'll click Unfold. And now we can pick a stationary face. So I'll pick this rear face as the stationary face. And we can pick what folds we want to unfold. We can click here if we want to select all the bends, to unfold all the bends, but we're just going to pick this lower one here. And click OK. And now we can see that the flange is now flattened out. And now we can go and use our regular commands to create our slot. So we'll go ahead and create a 2D sketch on this flattened bend. And I'm going to draw a construction line between the middle of the top of the bend and the bottom of the top of the bend. There we go. And for good measure, I'm going to select all of these lines using a right to left window and make them construction by right-clicking and clicking construction. What this does is create a line at the center, and at the center point of that line will be the center point of our slot. So we'll create our slot by coming to underneath the rectangle here. And we'll come to slot by center point. Next, we'll click the middle of our construction line. And here we can come up and we can draw the length of the slot, which is 12 millimeters. And then we can drag out the width of the slot, which is 4 millimeters. Excellent. And we'll say finish sketch. And now we can come to the cut command or the extrude command, either or. We'll say cut. And it'll pick up on that profile automatically. And we'll say OK. Now we can refold that flange. So let's go ahead and click refold. And once again, we'll pick our stationary reference, so the back of our bracket there. And then we'll just say refold all bends that have been unfolded. And we'll say OK. And there we go. We've got our slot that goes across a bend. Excellent, excellent. Okay, before continuing, we're going to save our file. So to do that, we'll come to File. And we'll click Save. And we'll put it in its folder. We'll go ahead and we're going to call it Sheet Metal Bracket. And we'll click Save. Excellent, excellent. Okay, so what we want to do now is we want to create a drawing of this. So to do that, we'll right-click the sheet metal bracket.ipt. And we are going to say create a drawing view. And you can pick your template at will. I'm going to pick my own, which is this Nemo one. Great. And for the client, I'll say YouTube friends. And we'll click OK. Okay. So now we've got the opportunity to place down our views. Now, when it comes to sheet metal drawings, I like to do two separate sheets. The first sheet shows all the detail of the folded model, and the second sheet shows the flat pattern. So we're going to go ahead and we are going to draw our folded model first. So let's go ahead, we'll place down our view. So we'll click here, front, and click OK. We'll drag our view into position. And then we'll use projected views to grab the top, side, and an isometric view for good measure. We will double click the isometric view and change it to a shaded view using this button here. Great. I might, while I'm at it, reduce the scale, so I'll click near it again, and I'll say the scale is 1 to 1.5. That's better. Great. And now we use our drawing command to add in some dimensions and some center lines to this drawing. So let's go ahead. The first thing that we'll do is we'll change the view to be, to show, oh, it's already showing hidden lines. Very good. Okay, so the first thing that we'll do is we'll go ahead and we'll add in some dimensions. So I'm not a great drawer in this sense. I don't have the patience for this video, but we'll go ahead and we'll add in some dimensions. So here we'll click Annotate Dimension. And just like with a sketch, we can add in our dimensions. So there we've got the height. And here we've got the width. Come on. There we go. And we'll also have the length. Very good. Good stuff. And we can also go ahead and we can draw center lines. So a center line is usually drawn by coming to Annotate and coming to this center line, center mark button, and then clicking your circles. But I'm a bit of a lazy guy, so we're going to use a lazy approach. Let's go ahead. We're going to click a view with the left click, then right click it, and come to Automated Center Lines. What this will do is go through the entire view, and it will draw center lines on particular features. So you might have holes or revolve features or punches, or you can even get it to do the center line of bends if you're being fancy. So here we can say we want to apply it to holes, which is selected by default. And we can also pick the front and also the side, which is not on by default. So we'll click it on now. And if you click OK, what you'll find is it will draw center marks and center lines for the entire view. We'll repeat this process a few more times. So we'll go ahead to the top view. We'll right click and say automated center lines. And here we'll click front and side and click OK. And one more time for the side view. We'll say right click, automated center lines. And then we'll click front view and a projection front and side. Great. Okay, if you want to do the exercise, you can go and detail this thing fully. Like say, for example, you can add the radius there and you might add in the angle here. I honestly don't like drawing. It's a bit boring. So I'll leave it to you. You can have some fun with it. If you are interested in a drawing video, do let me know in the comments below. It's just, it's not as fun as modeling, you know. All right, so that's our folded model drawing. What we want to do now, though, is we want to go back to our sheet metal parts and we want to make a flat pattern out of this. That is to say, we want to grab our folded sheet metal and we want to flatten it out. So the first thing that we'll do is we're going to define an A side. A side is just the part that is arbitrarily, you know, the stationary side. So we'll say define A. And if you hover over it, you can see marks the face selected as up. So you might say this face here is up. Great. Next, we'll say create flat pattern. And there you go. It automatically goes ahead and creates another model view with the entire sheet metal component flattened out. If you're eagle-eyed, you might have noticed that it says bend order annotation here. If you click, you can see the order of the bends and you can change them if you want to. So it might be that you fold these 3 first, followed by these 2. If you're a sheet metal worker and you know better, please let me know. Otherwise, I'm just going to show you how you can change the bend order. So go ahead to bend order annotation. And here we're going to go ahead and we're going to choose 1. We'll select this one here. And we're going to overwrite that bend number to 1 as well. And this one here to 1. And that one there also to 1. You can see that I've used 1 multiple times. That's because this is actually a single bend if you are going to use a sheet metal if you're going to fold this all at one time. Here we'll go ahead and that is number 2 and this is number 3. Looking good. Okay, so go to folded part. And now what we're going to do is we are going to save our model with Control S or hit the little diskette. And we are going to make a drawing of the flat pattern. So there's a couple of ways of doing this. If you wanted to make a separate drawing, you come to the flat pattern, you could say create a drawing view. But a better way of doing it is to come to the sheet metal bracket drawing. Just correct our drawing views a little bit. And here we're going to make a second sheet. So we'll come along to place views, say new sheet. And my template requires me to put in the client each time. So say YouTube friends. Okay, and now we've got a blank sheet and we want to create a new base view, but this time we'll click base. And rather than using the folded model, we'll pick the flat pattern. So click flat pattern there. And now we'll use the little green arrows to make it a little bit larger. We might say scale 1 to maybe 1.25 to 1. There we go. And click OK. And now we have a drawing of the flat pattern. So we'll need to do a few things. The first one is we're going to need a little table that will show which is the bend order and, what is the radius of the bend and, what's the angle if it was a flange with angles in it. So we'll come along here to annotate and we'll go and make our fold table by coming to General. So come to the Table tab and click General. Now we'll click our view. And as you can see, the general the general table function has inferred that we want to create a bend table. So here we've got bend ID, bend direction, bend angle, bend radius. Looking good. So we'll say OK. And now we can place down our bend table in the corner there. Great, great. Okay, so as you can see, our bend ID, we've got 1, 1, 1, 2, and 3, which you can see reflected in this table. Weirdly, they're not in order. Maybe we can fix that up shortly. So next, what we want to do, strictly speaking, you should include all the dimensions when you're making a drawing. But I find that when working with sheet metal, the ones that really matter are the overall dimensions of the sheet metal, as well as the dimensions of the fold lines. So we're going to go ahead and we're going to make some of those dimensions. We'll click baseline here, and we'll click this edge here, and then this point here, that fold line, this circle, the circle, the circle, the circle, this fold line, that circle, and the end there. We'll right click and say continue. And now we've got all of our dimensions at once. I love Inventor. There we go. Next, we'll do the same vertically. So we'll say baseline, click the lower edge there, and then click that circle there, this fold line here, and this circle here, and the top. Right click and say continue. And now we've got our dimensions in the vertical. And as before, we'll go ahead and we're going to retrieve the center marks. So we'll right click our view and we'll say retrieve automated center lines. Make sure that whole features are selected and click OK. And for good measure, we'll go ahead and add in a dimension there for the whole. Good, good, good. Okay, so you could detail the entire thing, but that might be a bit beyond the scope of this video. Okay, we're done. We had a look at how to make a sheet metal component. We looked at unfolding it and changing the bend order. We looked at making a drawing of it. I think it was a very, very fruitful episode. Okay, so let me know what you want to see next and chuck it in the comments below, and I'll see you next time. Thanks. Bye.